Hey everyone, this is section 4.4, Systems of Linear Inequalities. We're going to skip the system part for now and just talk about what is a linear inequality. It's just like a linear equation, except instead of an equal sign, we have things like less than, or greater than, or less than or equal to. We have an inequality in there. What we're going to do with these is we're going to graph them, basically, and we're going to end up shading the graph. So what you need to know to graph these is, at least the first part, is that whenever you see these symbols, less than, greater than, less than or equal to, greater than or equal to, they're going to tell you what type of line to draw. So if it's just less than or greater than, we're going to graph it with a dashed or a broken line. If it's less than or equal to or greater than or equal to, we're going to graph it with a solid line. Here's an example of an inequality with a less than or equal to, so that automatically tells us we're going to graph it with a dashed line. The first thing I like to do is figure that out and then go ahead and replace your inequality with an equal sign. Because basically when we go to graph this, we're going to treat it like a regular equation, and we're going to put it into y equals mx plus b and do all our stuff from there. So let's go ahead and do that. Let's solve this equation for x now. For y, so we can get it in y equals mx plus b. So we need to add a 2x to both sides. Those cancel out and we'll get y equals 2x minus 4. Now we can graph this equation because minus 4 is our y-intercept down here at minus 4. Our slope is 2, so that means we're going to go up 2 over 1. So from minus 4 up 2 over 1. Let's go ahead and put those points in. So minus 4 is roughly down there, up 2 over 1, roughly right about there. All we have to do now is just draw a dashed line that goes through these points, so very roughly, I'm going to do it something like this. And there we go, that's the first part. So there's really nothing new here other than the dashed or solid thing, so we're basically just graphing lines. The second piece, though, is once we have this line, so assume this is all the same line that we had from last time, same inequality, we have to shade one side or the other of the line. So this line's basically splitting everything, and either we're going to shade all of this side, or we're going to shade all of this side. And we're going to figure that out by using what we call a test point. Now the most important thing about your test point is that it can't lie on the line. This is the point 0, 0, which is right here in the middle, right? Notice the line doesn't go through here. So it's very important that you pick a point that's not on the line, and typically if your line doesn't go through 0, 0, we pick 0, 0 because it's very easy. What I mean by testing this is a point, x is 0, y is 0. We're literally going to take those values, plug them in for x and y, and see if we get a true statement. So let's do that. We'll take our inequality, minus 2x plus y less than negative 4. Let me dial that down a little bit. And we're going to plug in 0 for x and 0 for y. So it'll be minus 2 times 0 plus 0 is less than negative 4. This is why we like to plug in 0. It's really easy. Basically, this all becomes 0, and we get 0 is less than negative 4. Now, the question is that true or false? Well, 0 is not less than negative 4, so that's false. So what just happened is we picked this point over here, right? We tested it in the inequality, and it came out false. That means everything on this side, all of these points are going to test false, and that actually means everything on the other side is going to test true. So our last step is we're literally just going to try to shade this side of the graph, and this is kind of how you would do it by hand too. So this graph is now representing every single possible point that would solve this inequality. All the points on the line don't actually solve it, because since it's just less than, all these points will get you to be equal to negative 4. So that's why it's a dashed line. The points on the boundary don't actually count. But all the points over here, like this is the point 5, 0, for example, or 5, 1, or 6, negative 4, something like that. All of those points will solve this inequality. So this graph is representing all the possible solutions. So once you know how to graph one inequality, the only thing they can do to up the ante is to give you a system of inequalities, basically two inequalities. And the only catch here is we're literally going to do it twice. So we're going to take the first line, graph it, shade it, take the second line, graph it, and shade it, and at the end we're going to be looking for where the shading overlaps. So I'll kind of walk you through this. So let's start with our first inequality, y is less than or equal to 2x. Less than or equal to means it's going to be a solid line, and I'm going to go ahead and replace the less than or equal to with an equals, and that gives us this simple equation y equals 2x. This is already in y equals mx plus b. The b that's not showing is 0. So to graph this with a solid line, first thing we're going to do is plot our b, which we just said was 0. Oops, there we go. And then again, the slope is 2, so that means up 2 over 1, about there. Alright, let's go ahead and graph this with a solid line. Let me see if I can get my line tool up real quick. Okay, we're going to get a solid line. And it's going to go through these 2 points, roughly like that. Okay, there is our line. So now we're going to test it. We're going to test it with a point that's not on the line. Now notice, this time our line does go through 0, 0. That's why I'm not testing 0, 0. Pick anything that's not on the line. I'm picking the point 1, 0. Where is that? That is right here. Notice it's not on the line. Okay, so let's test that in the original inequality. 1 for x, 0 for y, right here. Or sorry, in this inequality. So we'll have y is less than or equal to 2x. That'll become 0 is less than or equal to 2 times 1, or 0 is less than or equal to 2. Is that true? Yeah, 0 is less than or equal to 2. So this time what we figured out is, this point right here we plugged in, we tested it, and it came out true. That means everything on this side of the line is true. So these are where we're going to shade. That also implies everything over here would be false. These are all the non-answers. So far, our graph looks something like this, and you'll see a better picture in a second. Okay, we've got our first line down over here that we just did, everything shaded. Now we're going to focus on the second one. This is a greater than, so it's going to be a dashed line. And we'll go ahead and replace the greater than with a equals, and we'll solve this for y real quick, which should be easy. We're just going to subtract x from both sides, and we'll get y equals minus x minus 1. That is what we are going to be plotting on our graph with a dashed line. So minus 1 is our y-intercept, which is about there. And negative 1 is also our slope. So remember, that means we're going to go down 1 and right 1 from that point. So from that point, down 1, right 1, and we're about there. So now we'll just draw a dashed line through these points. Make it a little bit. No, it's good. So again, I'm roughly freehanding this. Not the prettiest. And all of these kind of, when you do them by hand, they always come out kind of messy. So there's our line, roughly. It doesn't look like it goes through 0, 0, but we can... oh yeah, no it doesn't, because in fact my graph's a little bit misleading. This is the intercept, so it should just go right up this way. So it doesn't go through 0, 0, so we're going to test 0, 0 in our inequality. That's what I'm doing right over here. Right, so again, always go back to the original when you test. This is the original, so there's my original. 0 for x, 0 for y, couldn't be any easier. We get 0 plus 0 is greater than negative 1, so we get 0 greater than negative 1. 0 is greater than negative 1, that's true. So that means, remember, this is our line. We pick 0, 0, which is technically on this side of our line, right? Just very close, but it's right there. And we got that it was true. So that means everything on this side of the line is now going to be true. Get ready, it's going to get messy. Messier, I should say. Here is where we are shading. And remember, we're going from the red line, our last line, all the way up to that side. So the last thing is we're pretty much done. We just need to emphasize where the shading overlaps. Notice this was one of our lines, and this was one of our lines, right? See in this little corner over here, between these two lines, this is where all the shading overlaps. That means this is where the points come from that will solve both inequalities. Right, like the points up here, these will solve this inequality, but not this one. So they can't be a solution overall. The points down here, just the blue, these will solve the first inequality, but not this one. So it can't solve them both. Right? We want points that solve both inequalities. So when you do this by hand, you usually just erase this part, erase the shading you don't need, or sometimes you see people just circle it. However that works, you know, it's all kind of messy by hand. Let me show you how we'll do it here. Right, there's our graphing overlapped. And there's our graphing with the overlaps deleted, right? We deleted the shading here, deleted the shading here. Now you can see, hey, this region is where all the shading overlaps, and this is where our solution lies. So that's it. I know it's a lot of steps, but it's pretty much based on graphing, right? If you can graph lines, all this will come very easily. Let me know if you have any questions, and keep up the good work.